We can define the trigonometric functions in two ways. For angles between 0 and pi over 2, we can define these functions using right-angled triangles, which is what we're about to do now. And for other angles, we can use the unit circle, but both definitions are compatible, as we'll see later. If we have an angle theta, which is part of a right-angled triangle, as shown here, then we define the sine of theta to be the length of the opposite side over the length of the hypotenuse. So people often write this as sine of theta is equal to the opposite over the hypotenuse. And cosine of theta is the length of the adjacent side here over the length of the hypotenuse. So we have cosine of theta is the adjacent over the hypotenuse. And then tangent of theta is sine theta over cosine of theta. So tangent of theta, those hypotenuses cancel, and we have tangent of theta as the opposite over the adjacent. Let's look at an example. Here we're given a triangle. We have an angle theta which fits into this right angle triangle, but we don't know what it is. But nevertheless, we have enough information to calculate its cosine, sine, and tangent from this right-angled triangle. So we have this side is length 1, this side is length 3 over 2. We'll also need the hypotenuse for our calculations, so we have, according to Pythagoras, that's the square root of 1 squared plus 3 over 2 squared, and that's equal to the square root of 1 plus 9 over 4, which is the square root of 13 over 2. Okay, so that we now know that sine of theta is the opposite, the length of the opposite side to theta over the length of the hypotenuse, so that's 3 over 2 over the square root of 13 over 2. That's 3 over the square root of 13. And cosine of theta is the length of the adjacent over the hypotenuse, and that's equal to 1 over the square root of 13 over 2. That's 2 over the square root of 13. And tangent of theta is equal to the opposite over the adjacent, and that is equal to 3 over 2 over 1. That's just 3 over 2. We also have three other important trigonometric functions, which I guess they're called secant of theta, cosecant of theta, and tangent of theta, and they're just the reciprocal of the previous functions. So secant of theta is 1 over cosine of theta, and cosecant of theta is 1 over sine of theta, and cotangent is just 1 over tangent of theta. So for this triangle, if I want to find cosecant of theta, that's just 1 over sine of theta, and we had sine of theta is 3 over the square root of 13, so that's just the square root of 13 over 3. And you can see if sine of theta is the opposite over the hypotenuse, this one is the hypotenuse over the opposite. Secant of theta is 1 over cosine of theta, and we had cosine of theta here is 2 over the square root of 13, so that's the square root of 13 over 2, and that's the hypotenuse over the adjacent, pardon me, and cotangent of theta is 1 over tangent of theta, which is the adjacent over the opposite, and it's 2 over 3.